My name is Ian. My day job, I work at a company called Groupby. So today, this talk, on agenda-wise, we will do just a quick housekeeping, talk about my company, just like 1 minute. And we'll talk about some fundamental frameworks so that we can align on how we think about stuff. We will talk about, well, every talk is going to involve prompts. So we're going to talk about prompt as primitives. We'll talk about evaluation, talk about how do we think about vector databases, how we choose them, and have a last slide on basically thinking about product. So let's just quickly get into it because we don't actually have that much time. Group buy in general, just want to make sure everyone can hear me, yeah. At Groupby, we focus on having a AI-powered e-commerce solutions. So we have multiple different products. Our core product is search and recommendation from Vertex AI, but we have our internal tools, internal product that like data enrichment, guaranteed fitment that are internally built. Some of these we have some of the core components that comes with LLMs and vector databases. And from prototyping to production, we face many challenges, especially when we have low resources on the ML specialization. So we had to do a lot of basically explore, research, on the personal side, provide quite a bit of thoughts around product, architectural decisions and things like that, implementing them, and working much closer with product managers, SREs, and application tech leads. Specifically, these are all including for myself on some gigs on the side. We've gone through quite a bit of conversational and non-conversational projects. So really just focus on helping or sharing some experience. So in this workshop, we'll just focus on lessons learned throughout the past year or so. We will talk about things that we consider when we take things nowadays from prototype to production. Most of these are managed APIs, but many of these learnings and lessons are basically transferable whether or not you're doing self-hosting or managed APIs. So before getting everything into the LLM space, I want to get into the fundamental frameworks first, like mental frameworks. We think about these applications, not as an LLM application, but applications with LLM. Because if we think about LLM with application, then we mostly are familiar with ChatGPT-like stuff. It's going to be conversational and things like that. But there are way more applications, way more products, way more potential out there, and we want to treat LLMs as a component. Like every LLM component is just another software component. So every software considerations still apply. So you want to have, say, for example, constant product reality check. You want to make sure that you have micro milestones along the way, that you have a product market fit. You don't want to just get all excited, build a product that nobody uses. That has happened quite a bit over the past year or so, right? We want to think about coupling, right? The trade-off of having a tightly coupled system and not so loosely coupled system. This is true whether it's in code base, it's services, it's hardware. How about thinking about abstraction level? A lot of production system find problems when they use some of the orchestration wrappers out there. Maybe that is because their abstraction level is not considered right. When do we use self-build? When do we use managed system? When do we use high-level library? And when do we use a platform to specifically version your prompt? Some of the things that are less talked about is architecture-wise, you want to also think about your organization-wise architecture. So there may be tutorials that talk about, okay, we can just quickly develop into cloud functions, but that may not be how your security, how your policy, how your secrets rotation works. So those are the things that actually often come in a way. Team makeup as well. Not everyone is a Python or JavaScript, TypeScript developer. There are other languages. There are other specializations, non-ML specializations and experience that you might be limited to those access. So how do you consider that, right? And lastly, operations resources. Even if you push things into production, you need to think about not just application cost, but also who are going to maintain those. Some companies have DevOps to maintain their production system. Some companies have their tech leads to take more of responsibilities. So at some point, it might make more sense, for example, to use a managed service not because you're not capable of, because developers, we might have a little bit more ego on that, but just because you're not available, right? So these are all software components or software system that some of them that we need to think about. Another framework, like mental framework that we do need to think about, especially when a lot of the applications with LLMs are fastly developed, quickly pivoting, is think about the spectrum between flexible or being opinionated. So a lot of the decisions that you make in these systems are going to be jumping between these two. So for example, if it's just on the server, you have a bare metal, you control the physical, you control everything in the OS. It's very flexible, but it requires a lot of customization. You can have a lot of customization, cost saving as a result, but also requires time and capabilities to do the deployment. Now, the more that you go onto the managed side, that basically means you have a speed to deployment. Anyone can go on Vercel, yes, or Cloud Functions or Lambda and quickly deploy an app, but you're also subscribing to someone else's opinion of how things work. In the case of machine learning, if they say that you're building a model yourself with PyTorch, you can customize a lot of them. But maybe specifically come to language models, maybe you want to use Hugging Face that wraps around, that has a higher level wrapper that can make training easier, make using a pre-trained model easier. Maybe you don't even want to host your own model, then you're using OpenAI or Gemini. Or even you don't want to manage these vector databases or prompt manage APIs yourself. Maybe you are using LangChain, and there are some companies that are using LangChain in production. So that is the interesting part. In general, we do have some guiding principles personally, is where we want to be opinionated internally. It could be your code structure, could be your subject matter knowledge, your ontology. These are the things that we want to keep flexibility so that when things need to change around, we can pivot fast. But where you need to have the complexity abstracted away, then it's probably better to subscribe to someone else's opinion. And this also depends on the life stages, of your product. Two direction it can go. Bottom up, you start with the more flexible options and move up the abstraction layer when complexity is impractical. For example, you look at your deployment option. VMs probably are going to be cheaper, but is it practical for your scale? If it's not, then you probably need to move up to more containerization frameworks. But there's also the top-down. Maybe you're still prototyping. So prototyping with LangChain, stuff like LangChain is going to be easier because you're not sure about what's going to look like, what the application actually looks like yet. So you can just go from the top, more managed options, and then move down the chain, move down the abstraction layer when flexibility is not enough anymore in the code base. So it's good to investigate what is being abstracted. Doesn't matter if it's a hardware or code base or services, and just determine if you actually need opinions internally for that aspect, whether the hardware or code structure and things like that. For a specific project that we have at Groupby, this is how we do it. We generally are not using LangChain and Llama Index for flexibility and custom features from various components. Specifically, there are many vector databases available on these wrappers, but so many features of these vector databases are not going to be available through LangChain. through Lamanix or similar wrappers. But depending on your team, you might need to still use these wrappers. So everything is a trade-off. We also have a monorepo. So monorepo is you cannot have typically you have multiple code repos, but monorepo is where you have everything in the single repo, but you have multiple services that can be integrated. Google itself is famous for having the monorepo. So in the monorepo, we have separate services. They are in a lot of companies might be treated as a separate code base, but these different services are integrated within the monorepo and also in different languages because, for example, for a lot of web development stuff, might be JavaScript and TypeScript might be better. And each of these services are also deployed as a Helm chart on the Kubernetes. For these services to interact together, well, we actually use GraphQL throughout the services implemented in TypeScript. So this is not limited to just the AI services or the API vendors or interface with the vector database, but also just like a lot of operational stuff, a lot of backend stuff. And at the end of the day, we do have some stuff that we use Python and Ray for. These are when we need to have self-hosted models, which I'll explain a little bit where we use them. Need to auto-scale the computation. Then we do use it's good that they are in the same monorepo because then everything is a lot more transparent and clear in the same space. And the developers, whether it's the AI part or it's the product part or it's the application part, everyone knows what's going on. Taking things to a little bit light, let's first talk about like just simple stuff. The prompt part, and I assume most people here are familiar with prompts in general, so I'm not gonna go into too much of the 101 part. A lot of times your prototype may look like this, so imagine, so retrieval augmented generation, I'm borrowing this image from this paper, RAG for large language models, a survey. On the very left one, this one is basically how a naive RAG looks like. You have your question that comes in. You use your query to basically query your vector database and to find out, okay, the most relevant context. And then you just put the context and the question together into getting a context-driven question answering. So that's like the simplest version of that. People finding out, okay, question itself might not be enough. So before the question actually goes into vector database to go and search for context, then maybe you'll also need query expansion, rerouting, which will show a little bit what that may look like. And then you do a retrieval. And after retrieval of the context, you would also get into like re-ranking the context. Maybe some of it need to be filtered out or to be fused. And then that's how you prompt. But what they realize is as we have so many companies that actually get into the use case, every use case needs a different pattern. And when they see, search, predict, re-rank, everything, these are different modules and different patterns come together. Maybe we should just call it modular RAG. But if we actually go back to what we said before, everything is just a software design components. So, maybe this is just my little rant of we just think about it as a software rather than calling it a special thing. Yes. I will see how do I share, but yes, I will look to how do I share with the organization. Yeah, because I also have the collab notebook that is also attached to this presentation. So hopefully that is also helpful. Now, some of the things that you may run into, but the good question. Some of the things you might run into when you're using prompts, when you're doing actual RAGs, when you try to take it to production, you might find out, hey, chains are taking much longer to run. Because when you scale up the data that you face, you see much more variant of, much more different kinds of data. You see many more edge cases. So your chains are much longer. You might have some chains that don't that try to do multitasking, but they don't do every edge case well. And when you try to, let's just keep on prompt engineer, you find out you finally solve the edge case, except the old data, the old edge cases don't work anymore. So it's, at a certain point, it's hard to keep on prompt engineer your way. It can become costly to run, especially for conversational, because users will just keep on talking, and you might be spending money at every turn. Output might be inconsistent. Even the same prompt, same temperature, might not mean you have the same guaranteed output. LLM output might not even take into consideration of your context, retrieve from LLM that well, retrieve from vector database that well, especially for RAG. And this is mostly because there's a theoretical versus effective context length. And lastly, your AI programs, if you make it a isolated service versus an application, when you're trying to develop the greenfield project, it might become, the application tries to develop, tries to change its way, try to pivot, and it has a new requirement of how it receives the data or receives the output from AI service. But because of that lag, if they're not well connected enough, there may be a lag or a painful time between the teams to think about, okay, how do we develop next stage? We treat prompts as a primitive. Primitive doesn't mean it's just only a prompt. It's basically looking at them as a component. So primitives can be prompts, but it can be other things like having an API to your vector database, having an interface to a logic operation, and things like that. But specifically when it comes to prompts as primitives, we find what works better is if we can have prompts as first, as general as possible, and try to do single task. So if you actually keep them as single tasks, even though models are great at multi-step reasoning, multitasking, when you keep them at single task, it's usually better and consistent. It's better for flexible routing. It's better because you don't need a complicated output, so you can actually use less powerful models. You can even potentially train student models as a result. Smaller output also allow greater hits on cache. So if you have a very complicated output, then more likely you won't have a consistent output all the time. But if it's just like a single task, like a task classification, that type of thing, then caching might be a lot easier. And when you can hit the cache a lot more times, that means faster and that means cheaper. So this allows you to be more token efficient as well. Primitives, in general, when you break it down into subtasks, because you're not generating as many tokens at the same time. And you also have a speed gain because of it's a single task. It's concurrent. You can run it concurrently. You can use smaller models and even train your own small hosted models. So it's amazing in that way. And lastly, because of everything we mentioned above, you have a better control on costing. Now, here I do have a little demo. It's not a production system thing at all. It's going to be on Collab Notebook. But it is something I want to demonstrate how you would think. If you're just starting this journey, you may think like adding more prompts means adding cost, but it's actually not necessarily. So in this way, let me just make sure I actually have a hard time seeing this and that, but I'll try. I did install this. I think they look fine. Let's just imagine, this is a very cherry-picked example, obviously, just for demonstration purpose. But let's just imagine this is our website. We have an assistant that tries to answer, we have search AI, we have data enrichment, we have fitment solutions, different kinds of product. So what are different kinds of product about? And just imagine we have an assistant that's doing this. This is an attempt to actually replicate another project that I have, but like at a very simplistic level. So this API code will be invalidated later on after this presentation, so we don't need to worry about this. But the few steps are we have parsed the product pages. You can see that these are the different pages that we parse, and then use the LangChain semantic chunking, semantic splitting to put them into different chunks. we are saving them into LansDB, a vector. Oh, sorry. Zoom in more, like, oh, okay. Let me see. Am I able to? Let's see. Where are my mouses? Okay. Maybe like this. Does that help? Okay. I'm gonna turn off my my mouse for now. Okay. So, okay. Let's see if I can do it like this. Otherwise, my head is, and where's my mouse? Okay. Well, we'll see. Okay, so each of the chunk in the vector database, in this case, a LansDB. LansDB is great for embedded vector database. So as in, it's part of the application. We will have the page content as the source of the vector. We will have the vector field, and then we'll include metadata like page and source. And what that looks like is, I cannot find my mouse. Sorry, I'm having a hard time with this. Where is my mouse? Oh, there you go. Okay, I'm just gonna quickly go down. I think I have ran this just in case. Oh, okay, yeah, it already exists. Anyways, so we're going to first instantiate the client, OpenAI client in the table. And what this means is the table is from the, okay, so as you can see, let me try to zoom in that a little bit. As you can see, we have the page content, and so that's the source of the code, of the vector, and this is the vector being stored. We do have metadata that says, okay, this is from what page, this chunk is from what page, this chunk is from what page. And we also have another logic that says, okay, if it's about company or contact, the source is about. If it's other product pages, then it's the source is co-product. This is so that we won't be using the source part, but having metadata is quite important for your vector database to be more efficient later on. So let's first try this, okay? Given a question, a simple RAG, given a question, let's query 10 chunks as the retrieve context, and then we answer the question based on the context. So what is the question? The question is, what is the data enrichment product about? Okay, so we will just use the same question throughout, and we'll just show how, with Mermaid, how on the diagramming part. Okay, let's actually run that first. Okay, so again, so it is a question. When the question comes in, it first hits the retrieve a context and 10 chunks of them, and then to do a simple, nothing fancy, nothing else, to just do to inject context as part of the prompt and do a QA. As you can see, you are a helpful assistant to Groupby. You're trying to help the potential customers to answer their question. We will inject the context and question. So this is the context QA part. And let's see. Okay. Okay, it actually has a better output than I expected, than many times I run. It does have, some structure. It took about 255 completion tokens, so that's what it generated. But we do have quite a bit of prompt token, and but it's a lot less cost compared to what we're gonna see. So 0.4 cents. But let's just change the model, because this is the 3.5, and let's just see how much better, maybe, and maybe possibly longer GPT 4.0 could be, because 4.0 is the newer one, right? So as you can see, it's a lot more complicated, a lot more structured, and they try to have some markdown as well. But the problem is, you can see how we are tracking the cost, right? We are tracking the cost, and it took 4.5 cents to generate that. So that is not sustainable. So what can we do to maybe slightly do it better? We can add a prompt. What do we add? So here, it's still the same thing, add the question, but after we retrieve the context, maybe we add another prompt to say, hey, given this question and the context, like the chunk, is this going to be answering the question or not? And then basically you have a yes/no output. And you filter, instead of just sending 10, maybe at the end it's only 5, it's only 2, and then have the shortened filtered context as part of the context QA. I'm gonna run this, but so that we save time. But you can see how this part, given the question, text and question, determine if it can be answered, if it can answer the question. Output is yes or no. And this is basically how a typical JSON output would run, because you can actually say, okay, if it's yes, then you keep it. If it's no, then you filter it out, so that we only get a shortened context. After that, we can see how it took. This is GPT-3, I think, 3.5. It is a lot cheaper, but sometimes, but the content is still not that great, and it's still. Oh, actually, this is, yeah, the output is still, the question answering is still GPT 4.0, but cost, we went from 4 point something to now just 1 cent, right? So by filtering out context, there is something, but can we go even more? Can we go even more, right? So remember that we actually initially have metadata that says, where are these pages coming from? So we're gonna continue to add one more prompt, okay? And this is basically when the question comes in, before we even send it to a vector database, we send a prompt to say, hey, here's my question. Can you determine which pages might be able to answer this? And then we can then go to the vector database and have metadata filtering so that it only retrieve chunks based on that metadata, and everything stays the same. So if I run this again, so this is the additional prompt, right? Based on the question, return the applicable context category to the following, and these are the pages. Output format is basically pages of basically an array of different pages, and then have the question come in. So in the end, we still have we still are using GPT 4.0, and it does take still like roughly the same amount of time, 1 cent, but the content is okay, larger, and there you go. And there are some times that you can actually, when I was playing with this, there are some times where even 3.5 can actually achieve the same result. It's using much less tokens, and it's also achieving much less cost. But because we're not optimized yet, so this is not consistent. One of the things I want to, as a takeaway, is, well, first of all, we know that this is a very cherry-picked example. We know we didn't include schema validation, so if you actually go and run this, you might need to run a few times. It's not consistent because temperature is not set, and caching is not included. But as you can see, when we add more prompts, when we add more primitives, it actually becomes, it doesn't necessarily have to become more costly. It actually can become more interesting. And the interesting part about this prompt specifically, the based on question, return applicable context, right? This one can actually, it doesn't have to be about vector database. If you actually replace the based on question, it can be based on text. Say that it's a customer support ticket. We can use the same prompt to predict, hey, this customer support ticket, is this more of a data enrichment product, or is this more of a search AI product? So the same prompt can be used for different things. And that's why it's called a primitive, because we're not trying to restrict, we're trying to make it more multi-purpose rather than just doing using the same, rather than just in a single chain. So this is how we actually do it in the production. We do have the mono repo. We do expose all of them as a primitive. There are some more generic ones that are more just bootstrapping NLP models. So text classification, summarization, we can have filtering, logic operations, and interacting with vector database. Your typical schema validation and output validation with Zod, that's on TypeScript. And then we expose everything through GraphQL. GraphQL, as opposed to REST API, allows much more flexible API usage from the client side when they're retrieving context or using your API. And we do this GraphQL part not only with the API part, but also with we have other services like auditing, office worker that dispatch the tasks and everything like that. So we have these exposed as GraphQL, and rather than AI people spending time thinking about how do I do chaining and everything, you actually when you actually open up as a primitive, you enable application developers to do their own chaining, to do their own operation logic, to do their own logic and everything like that. And we don't need to necessarily say control too much on the prompting. We can actually just allow them to add specifically more guardrails. Maybe they can check with if it's the right feature to be open up to the specific customer. And you have the QA engine, you have the guardrails to make sure that the bad output is not output. It's not sent to the client. So again, some of the tips include theoretical context length is not as long as it's actually relatively, so the effective context length is actually relatively little compared to the theoretical context length, especially for the open source models. It's not as true anymore with say things like GPT-4, but you do want to be careful about it. And when you put them down into subtasks, it's a lot more consistent on being able to take care of your context. Complex JSON output also may, if you have nested arrays and everything like that, it might mean you have in the case you have more potential sub-problems to solve for, so you can try to break them down even further. But again, you don't want to over-engineer prompts, but rely on guardrails, rely on verification, rely on QA to make sure that your output is fine for the customer. Otherwise, your prompt will become very brittle to edge cases. And at the end, if you're doing self-hosting especially, you want to track your token usage and time to completion. And especially for self-hosting, you want to track not just requests per minute, not just requests per second, but also requests per minute. Because for self-hosting, you're adding up a lot of the, as computation and things get cached, more often than not, when the requests come up, your model might actually become slower and slower. So tracking your requests per second and requests per minute and up to maybe 2 to 5 minutes is probably better for you. Keeping track of these usage is important. Now that we got away with more, I guess, let's just okay stuff, we're gonna talk about more how we think about prompt versioning. So prompt versioning, when we think about prompts in production, there are going to be multiple subject matter experts, or the other case might be you have no one to prompt. Rarely is the case that you have a consistent person that prompts before production and after production. And so we need to think about how do we version the prompt. What is the case of no one is there to prompt? Because so now when you have developers to do the initial prompt engineering, because they are not subject matter experts and they might not want to be they will be dreaded to be a prompt engineer. It's probably not the best to have developers on that title or to do that work. So, so that's also one of the problem. Another problem might arise when your prompts are hard-coded into the code base. Actually, now I wonder how many here actually have prompts hard-coded in their code base right now? Oh yeah. I don't know, if put into a production, and well, not saying it's a very bad thing, but you probably realize that whenever you do if you constantly need to optimize it, just a simple change may cause the entire CI/CD you wait for it for a long time. And the developer side, it also, especially when your orchestration becomes much larger, we also face the same problem. Then it becomes hard to test. So when we look at prompt versioning, we actually look into, we're still, this part is still being designed and investigated, but we did find there are two paradigms. One paradigm is having more empowered subject matter experts to actually do this versioning. Human Loop is one example. I like their model. Let engineers do the engineering. Let SMEs do the prompting. What that means is their platform allows engineers to just focus on the schema validation, because that's what developers care about, and include some data sets on the platform, allow the subject matter experts to just write prompt. As long as their scoring to those data sets work, it can be deployed, and it will be just configurable to replace the current prompt. So that is one way for one paradigm of how prompt versioning is being done. Another paradigm, when you don't have that many SMEs or to work with, then it is on the automatic optimization. So I believe some of you might have heard of today on the DSPy part, and DSPy is one way of doing the automatic optimization. So given a goal, you are the program or the library will just optimize the prompt for you instead of you trying to fiddle with the words. Other ones include like just more modelly, like the prompt tuning that goes straight into the model and things like that. But either way, it's either empowering more of the SMEs or having more of the automatic optimization. How we do it, this is actually one of my favorite slides because it's fun. How we do it, on the right-hand side, the chart is, we're still designing on this, but on the left, let's just briefly talk about how we actually do how it actually happens. Context and metadata are basically based on user session. When a user session starts, this is in web development part, you would have context specific to that user session, and you have metadata that may say what model or what vendor to use. Because for us, a lot of user session is basically having a task. You have a ticket and you have multiple tasks to run, and each of the primitives basically can represent a task, and we basically do have an office runner to collect. Okay, based on this ticket description, these are the tasks to run, these are the primitives to run, and let's dispatch it. Now, in the LLM completion part on the left-hand side, that is an actual class that we can configure to, okay, based on the API, based on the model, based on the vendor, this is what it is. But because this is a configurable, we actually also allow human agents as well. So a primitive doesn't have to be completed by a machine. It doesn't have to be completed by APIs. It can actually be completed by humans as well, because humans can also do the labeling. Humans can also do the design. And some of the edge cases, like you have a special customer, you might not trust the models as much. So making it configurable, we can actually allow human in the loop type of orchestration happen without changing the class or without having a special class. So primitive library, again, it is trying to be vendor and model agnostic, and it's even trying to be more like how it's executed is also more agnostic in that sense, because you can also switch it out and have human agents to do it. Once you have the output validated by Zod, boom. So this is the part that we already designed, and hopefully this is one fun thing. On the right-hand side, though, is something that we're still deciding how to do it, like specific implementation detail. But we do know that prompts will become most of the prompts, if not all, will become more of a configurable. Might be a config map on Kubernetes, might be another platform that we build. But because Human Loop and other vendors are not as they're not as flexible or feature rich as we wanted, so we're gonna just build our own. But in general, it's the same thing. You have a configurable prompt that you want to improve on. We have large number of prompts that need to be done by taxonomists. They are our SMEs. There are some small number that needs to be done by DSPy. Our application natively produces silver and golden data sets, which I'll explain in a little bit. Once the golden data sets, once there is a better scoring going down, we can just automatically change the prompt in the configuration. And when you make it a configurable, that means even if you change it up, you're not trigger. You don't have to trigger the application itself on the CI/CD level, because our integration test, for example, right now takes hours to run, but I don't need to test my prompt and just wait for hours to test my new orchestration or my new prompt. So when you make it more of a configurable, it basically becomes what we say, it's the same thing as model versioning. So prompt versioning should be treated as model versioning. It's the same thing. Keep prompts as configurable so that you can decouple prompt versioning from application code base. Their tests should be separated, their integrations should be separated, but standard tests and traffic split, like when you do the testing on the golden data set, when you do the traffic split on the testing, they should all apply. It's the same thing as typical models. You are also looking at different types of data sets or different quality of data set. We call it silver and golden, and this is mostly because of I do come from more of a information extraction space. So in the NER space, name entity recognition, there's a lot of concept about basically golden and silver. You're also basically looking at application automatically produces data. Some of them can be automatically say, oh, this is good, but some of them might need to be validated by human. So you need to basically flag if your data set is silver quality or golden quality. Golden quality meaning it's being validated, it's already been validated and curated by humans. And you wanna make sure that maybe you're not doing as hot in your new prompt, new model, whatever, it's not doing as hot on silver data set, that's okay. But golden data set cannot drop because those are very important. The golden data set, how you curate it also matters, but that can be a little bit in the next stage on the evaluation. Actually, let's just get right into it. So we're talking about like golden data set and validation. What is validation? What are we evaluating? On the evaluation side, there are many questions that I keep on hearing. For example, how do we evaluate when there's no ground truth? What is reliability? And question, how many of you have heard of this phrase? I need the output from LLM to be 100% accurate, or if not, at least close to accurate. Have you guys heard of it? Yeah. I hear that every single day. But it's it's not easy. It's also not practical. So what is reliability, right? And sometimes you also have like undesired output that comes out. You have it can be expensive to run. There are some evaluation methods that are LLM-based. And they can actually be expensive to run. And it doesn't make sense if your evaluation actually takes more money to run than your features, right? Why would that just doesn't make product sense. There are libraries like Ragas that try to do these LLM-based evaluation, but they are, they don't really address everyone's use case, and it can feel like it's arbitrary. One example is, for example, this relevancy, answer relevancy. You might, I wonder if you can see, let me see if I can enlarge it. So, for example, one of the way that they do evaluation is called answer relevancy. Oh, shoot. Answer relevancy, and then it's basically given a question, like it's basically, oh shoot. Maybe I can leave it as a separate example to be read later on. But you can see on the bottom left on how it works. You basically are given answer and question. They have a prompt to say, okay, given your question, let's generate, given your answer, generate some possible answers. So for example, on the top right, you have answer that is Everest. What possible questions could be there to actually have that type of answer? So they generate, they ask the model to generate different kind of questions, including, say, what is the tallest mountain on Earth? This type of, after they generate that, they will compare the similarity between the original question and generated question. And then they take that mean similarity with this very hacky formula in a way. They basically look at if the answer is vague or not, and if it's vague, then it is non-committal. If it's not vague, then it's committal. And so they're looking at mean similarity multiply by if the answer is actually committal or not. And that generates a few questions, right? Like, it's trying to be reference free, meaning you don't need a ground truth, which is interesting. But but that also means like extremely short answers can be punished. Say, for example, if the question is Paris, then answer could question could be, for example, what is the capital of France? Where was Philippe born? And these two are very unrelated questions, but the answer could be Paris. So extremely short answer might be punished as a result of the similarity. Similarity are not relevancy. Relevance is based on context, based on use case. And the last part on the integer on not, so it's a inverse operation of committal or not. That part reads more like a hack, because when they do this prompt, the same prompt actually can have both committal and non-committal happening at the same time. And so they just want any result that has a non-committal to be punished. So these are actually not answered quite clear on their documentation. There were many more examples of this that I did at Aggregate Intellect when we did the LLM problem solver. I did have a deep dive into all the metrics, but they don't really show this on the documentation. You have to dig deep into the source code to understand how they do the calculation. And some of these include faithfulness, correctness, and things like that. But it might be too hacky for people. So when you try to use these LLM-based libraries, you probably want to dig deeper into if they make sense for you or not. Back to us. We're evaluating for quality. We're evaluating for go, no-go decisions. These are the reasons why we're doing evaluation. And we also need to know if we need to have what kind of UX UI design do we need. So every step along the way, we don't try to have a comprehensive benchmarks. Like from the get-go, we actually just identify what are the critical metrics that we need in order to have a next stage to happen. So you might need to iteratively build up your benchmark, your data set. And we also try to do more lexical-based metrics and other non-LLM approaches. We do have the concept of a QA engine for our LLM data enrichment product. So what data enrichment really is about when the client catalog comes in, can we actually create structured data and create more of a normalized data? For example, product may call it maroon, product may call it crimson, but we actually want the word red to identify that product. So that is a lot of those, that includes, say, data strategy, construction and everything like that. We need to check the output, how good is the labeling, how good is the organization of data and information. So we do have a concept of QA engine. We already implemented the infrastructure. It is trying to do multiple custom metrics to triangulate a proxy. It is trying to avoid more LLM-based metrics for interpretability, because we do want more of a 0 to 100 scoring. We are using Ray because of not using LLM-based metrics. So we are using Ray to auto-scale the computation from GPUs from 0 to n for parallelized batch jobs. And because it does help to go from n to back to 0, the auto-scaling really helps. And in some cases, actually, some of the larger catalog can actually drop the cost to an order of magnitude cheaper, which is quite important in that way. So I love Ray. Whoever, if they are Ray developer here, I love you. And and then there are also in our golden data set, we try to include two things. We try to include some hard cases that are probably hard for the model to actually figure out. So we want to evaluate them separately from just generic cases. We also try to include some bad output to make sure that the guardrails are working, because you never want bad output to go out. it's not perfect yet, but we are both evaluating both the inference quality as well as if the guardrail can actually ensure no bad output is going out. How we do it, just imagine like when a catalog is finally enriched, we will do some batch job. We basically will trigger multiple rate job to evaluate them. One of them is basically based on NLI. NLI, see if the alignment agrees with the labeling from the model. So that is one metric, but we can also have some lexical-based metrics. Say if there are punctuations, or if the word length is too long. It's probably not what we want for labeling in our case. So we also look at like simple metrics like that as part of the punishment. And there are also customer-specific preference on how labeling should be done. So that is also something that we want to implement later on as customers use it more often. And they all come together to be come to a final scoring. So the purple part is what's already been implemented, and the other ones are like basically coming soon. But having these different metrics to triangulate the quality is basically how we go about it. Now that we talked about the prompting and everything like that, I think vector databases is the fun one. Personally, I love talking about vector databases just because almost all the use cases or projects that I went through have them, and there's always a debate about which one, like choosing which one. Actually, how many people are still deciding which vector database they're going for, or have ever? Oh yeah, okay, at least some. The problem with vector database is there are so many of them. There are tutorials-wise mostly are based on ChromaDB, and sometimes when you're trying to bring into when you're developing a greenfield project, it can be convoluted in terms of you're trying to. In general, like the data modeling, there's the application data models, and then there's the like for data analytics, and they may have like different data models and things like that. And if you're doing data engineering within your vector database for your knowledge base, maybe you find out you cannot just have simple chunks. Maybe you need to have a multi-hierarchical, like articles referencing. Paragraphs referencing articles, referencing like magazine or things like that. You have multiple hierarchical. Maybe you find that works better, so that's a data model change. But maybe that breaks the application that you're trying to develop. So this, when you have data engineering work being done by the AI people and having the application people doing their own thing, it becomes a convoluted debating about how to go about things and hard to align on. And lastly, it can be expensive to run on the cloud, like some of the managed vendors. So how do we even choose one on the vector database? One thing that's interesting is most of the questions on how to choose a vector database is the same as choosing a generic database, right? You think about how your application is going to be interacting with the data. Is it, sorry. I did not know I could choke myself like that. Wow, okay. So yeah, a lot of the things are actually the same. You can think about how read works. Is it mostly a read operation? Is it mostly a write operation? Is it going to be batch for analytics? Or is it going to be mostly a concurrent run, a concurrent query in real time? Like, there's a lot of questions about that. How are you going to sync the data? Maybe there's race condition. Maybe there's how do you do the concurrent writes? How do you ensure the global availability if your application has to be around different parts of the world? Maybe there's the multi-data center replication. So replicas in the same region might work well for like just in case you need backup. But what if the entire region is down? Because that does happen, even if it's AWS or GCP, right? So how about that? So, and are these going to be, do you want to manage them? Do you want to manage them internally, or do you want to just let someone else manage it? Those are the type of problem that when you choose a database in general you do think about, right? And so it's the same with vector databases. You do think about, do you want in-memory dedicated database and various problems. And just by thinking about these fundamental questions already help you to shortlist a lot of the options out there. Then there are vector-specific questions. For example, what data is going to be vectorized? Are they native to the application, or are they a separate, isolated knowledge base to be managed? What is the evolution of this data look like, right? Is it going to be a constant update? Is it going to be coming from the same source? How large is the scale? And can it be broken up into multiple pieces instead? So some of the trade-offs that at least how I see it, specifically on the extension versus dedicated, this one is where most debate or opinions are, because people will say, oh yeah, I have Postgres. Why not just use Postgres? And Postgres is improving, PG Vector is improving. But does it make sense or not? It depends, because on the spectrum of where the data should be vectorized, if your vectorization, like the data that you need to vectorize, is native to your application code, say for example, your Mongo stores your conversation, then extension makes sense. But if it's something that that is totally different from a whole new database, a whole new knowledge base that you want to work on, say if it's scraped content from somewhere else, but your application itself has nothing to do with the knowledge base, it might be better to actually use an isolated vector database, so that the data engineers that's focused on that, on managing the knowledge base, what makes a better prompting, what makes a better retrieval, can work on themselves rather than doing that. So if the data to be vectorized is native to the application, go for extension. At least try the extension first, because extensions are getting better and better. But if it's an isolated one, it's an isolated knowledge base, then maybe try a separated, dedicated database. And obviously, there are going to be a hybrid version where you have conversational that needs some RAG. If you have the bandwidth, try both. If you don't, maybe still try the extension, although it will be quite annoying when you try to do the development. Another trade-off that people need to think about, because everything on the architecture is trade-offs. Are you doing more self-hosting, or are you doing more managed hosting? And right now, some of the things, it's flexibility versus opinion. This one we already know. But one thing that I do find is, I don't think these dedicated vector database have global availability yet. As in a very easy way to do multi-data center replication. So if that's a need, you might need to think about how you're gonna manage that, or it might be better just let someone else, like the cloud vendor, to take care about it, rather than you trying to go and manage that. Another thing you might need to think about on the trade-offs, you might need to think about the vectorization methods. Specifically, if you are using some custom train models to vectorize, to create a vector, it could be because you have a multimodal vector database, or could be because you have a specific domain, like bio, then you need to really think about how you want to do the computation, because it is an added up computation to your hardware. So if you're doing self-hosting as well as internal model, the custom train model like that, there's a lot to manage. So maybe it does make sense to have your custom train model locally still doing the vectorization, but use a managed vector database on the cloud, so that you don't need to worry about too much if your developer resources are restricted or constrained. You might also want to think about what features are available. Vector databases are interesting in a way that they kind of came out of recommendation system. So a lot of the features that they continue to add will be about kind of like similar things like that. So easy way to add a re-ranker, a hybrid search, like a full text search. So you consider both semantic as well as keyword together. There are also, like, say, for example, Kubernetes operators, so that you can operate on the Kubernetes easier. developer interface is important. For example, are you going to use a language-specific client, or are you going to use their REST API or GraphQL? Features such as disk ANN is very good for speed gain, because not everything is just um, yeah. So this ANN is also there for embedded database. Not all vector databases also support the desired features. So you also, if there are like specific features you want from vector database, that also helps shortlist the options that you want to have. You might think about this is a bit much more niche, but if costing matters, like, because if you have it at a super large scale, maybe indexing and quantization methods available also matters to you. But that's something even I think requires a bit more investigation. And always check on the development plan, because I find that not all vector database try to do everything. Some of them just completely give up some of the features. Hybrid search, native hybrid search is something that some vector database completely give up on. So if you actually need that, then you need to think about where to go. How we do it internally though, we have, oh, where is my mouse? Oh, there you are. There you go. How we do it internally, there are two applications, two projects within our company that use vector database, and we do use different ones. Based on everything, all the trade-offs that we talked about, one of them is a Java application that exposes API to other applications. So we opted for Weaviate because Weaviate has Java client, and so it's a lot easier for that developer to actually set everything up. Because we have a limited resource on that department, like basically just one person, so we actually decided to use the cloud hosting. So as in the cloud managed version of Weaviate rather than self-hosting Weaviate, because Weaviate you can also self-host on the Kubernetes yourself, but it is a lot more to manage. So that is also a decision why we went on the cloud. On the cloud version of that, it does mean we need to pay a little bit more, but it was kind of worth it, just because if we want to manage them ourselves, then we need to pay more developers for that. Also, another thing is Weaviate does come with a native multi-tenancy. That means even though everything is in the same vector database, we're dealing with multiple B2B clients, so they can, the application should only have access to certain content, certain catalog at one point of time, depending on which client it is. So based on these reasons, we did offer the Weaviate on the cloud. But that's not true for the other application. So it's important to not just be married into one database. And as you can see here, we actually opt for PG Vector, which is just an extension of Postgres. Why is that? Because our TypeScript and Python application is actually already using Postgres, first of all. The content that we need to vectorize is actually very native to the application itself. Even without the vectorization need, the tree, the catalogs being built is already there. It's already native to the application. So whenever there's a data model that needs to be changed on the application, the data that needs to be vectorized will just will just be changed at the same time. There's no, okay, I need to change my data models. So-and-so developer, AI developer, data engineer, please also change everything on your side. Because the data to be vectorized is native to the application, so we opt for the extension. Now we also know that PG Vector doesn't have native hybrid search. It doesn't have native re-ranking to easily add re-ranker. Say you're using Cohere re-ranker, you want to easily add to it. Dedicated vector database allows you to do that very easily, but for Postgres, it does mean that we need to do it separately, but we do have more developer resources on that end to basically do that custom computation. So we went for that. Last but not least, I want to talk a little about just one slide, but on the product, because after talking to so many different projects and having to think about product, there are some common problems or topics that keep on coming up. And so I want to take this chance to also talk about them. Now, first is the trend chasing thing. There are so many papers, so many new developments, so many new libraries that keep on coming up. It's hard to keep up. And it's hard to know which one is a fad, which one actually will stay. And it's also an everyday thing that product managers might get excited about certain new development, which makes sense. People get excited, but it doesn't mean that we should jump into features like immediately, feature building immediately. So it's good to have a group of different people, a group of experts from multiple perspectives to think about that, because there is a lot more noise than signals in the ecosystem right now. At least that's how I personally feel. So trend chasing might be a problem that you might face, and it's good to develop some sort of, I guess, authoritative voice, as in like you have an voice of authority to help you out on to communicate with different stakeholders. One thing that's always missing is the pricing model, because it's exciting to build a product, really exciting, but as you can see in the previous one, cost is quite a bit, and when we continue to build new features or pivot, we on the aggressive milestone to do a product reality check, pricing is also part of it. Conversational, for example, if you're using prompts every time, then you might just naturally build up a lot of cost without any revenue coming in. So one thing that we try to do is also whenever we have a cost change, and cost tracking with LLMs are not easy. It's not like, oh, we're gonna project, we're gonna have this many users, we're gonna have this hardware, so it's probably some consistent costing. Like you can have a relatively more consistent costing around that. LLM costing, if you're using a managed API, it scales with the users, and depending on your routing, it might go your bottom line and your top line might differ a lot. Even if you do self-hosting, you cannot just reserve, unless you're super rich and you want to just reserve multiple GPUs. You probably also want to think about that auto scaling, and hence costing is not an easy thing to estimate when it comes to using LLMs. And at the same time, then it also makes the how do you think about the revenue generation very important. So if you have control or have some voice on the product, I highly recommend always think about how you're gonna recoup that cost, especially when that cost is really not that easy to estimate. If anything else, that is important. Application design-wise, there are definitely more designs than just conversational. As we saw, we put everything on primitives, and LLMs in particular, I love it as a bootstrapping model. Meaning, I don't need to go and fine-tune another BERT-based model and if I don't have the data to even fine-tune, it's hard. But LLMs are great for bootstrapping for when you don't have the data yet, and when you need to just have some NLP tasks to be done for. There are so many more designs that you can use for LLM other than the conversational ones. Data engineering is a space where I'm excited about. I'm not a data engineer, but I love looking at the marvels, the miracles that they bring. With vector database, if you're doing RAG, there's going to be a lot of data engineering. There is going to be a lot of data modeling to have, say, a different chunking strategy, etc. So that's just one aspect of data engineering that I think will probably have more platforms focus more to help that out. But another space that I don't think is talked about enough is the data quality in the pipeline. Wherever you get the text data, or unstructured data, whatever, it's going to be coming from somewhere. Now, we do know if you have some in the data pipeline, there are libraries like Great Expectation, like Soda, that helps to evaluate, hey, what is the statistical properties of these numeric data. Are they good? Are they within the standard deviation and yada yada? So there's a lot of data validation for the numeric data. But for unstructured data, such as text, such as images, there's very little. And like maybe validating character length, maybe validating some stuff like that. But on the open source libraries, it's not enough. I'm sure that companies build custom quality check within, but I do think that there is some, I don't know, greater opportunities on the data engineering, specifically on the data validation side before they actually come into the application. I do suggest, in general, it's good to consider where you're gonna separate the systems so that data engineers feel more freely to do their own magic, as opposed to always being coupled with the application developers and always and stuff like that. Another problem that I do hear about is sensitive data. And how many people here are actually dealing with sensitive or regulatory? Okay, there you go, quite a bit. Now, you can correct me if I'm wrong, but from the multiple projects that I see, it's often an easy thing to say, oh, my industry is highly regulated. We can only do self-hosted models. But that actually is because if you actually think about it in a more system level, but if you actually drill down to what you need to use LLMs for example, we just saw the primitive part. A lot of them don't necessarily have to expose, say, personally identifiable information. Say, maybe it's something that's more like client-specific data. And there are plenty of libraries out there that either do masking, placeholdering, or even synthetic data. And a lot of the times, if you break it down to sub-problems, you don't actually have any information that's PIL sensitive. So it's actually good to do two things. And so likely your system, if you want to catch up, unless you have plenty of money, is you're gonna have a hybrid system where some of them that can be easily solved and not as sensitive can be easily solved by a cloud provider, a managed vendor. So it's good to investigate what is the granularity or the locality of your sensitive data, exactly what is a problem. And this probably is a lawyer talk as well. I'm not so sure how that's gonna work with the regulatory part, but there are active development at this on this front to make sure that not everything has to be self-hosted, and investigate into how you can use maybe some sort of hybrid system may actually lift some of the heavy weight that you're encountering right now. Lastly, we talked about the reliability part. I learned about this and from reading the book, Designing Data Intensive Applications. Love that book, not a plug. I don't know them at all, but I just love that book. Actually, how many people here have read it? Designing Data Intensive Applications? No? 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 I think so. I think it is, right? Okay. Yeah. So this is one of the big takeaway from me. This point is we keep on hearing about like I need 100% accurate output, but it's impossible. It's impossible to have 100% thing. So a good thing is to think about the apology part. So and this is completely taken from the book, where if you think about it, airlines are not supposed to oversubscribe your tickets, but they're gonna do it anyways. And they're gonna apologize to you with some sort of benefits. And as long as they don't do it too often, the benefit of oversubscribing to them versus the cost that they have to apologize is just much greater. So it's the same thing in a lot of these architectural design. You think about, you don't think about you won't mess up. You think about what do you do when you mess up? Can you mess up? And what's the acceptable apology from the user point of view, from the system point of view? For example, when you say 100%, that's probably not true. Maybe users already expect maybe only just 70, 80% only work 70%, 80% of the time. They already know models are not perfect. As long as the post edits, they don't have to do it too much, they probably are fine with it. Like when you use Notion or when you use some other note-taking app and they all now have those prompting, you as a user, you probably expect you're gonna write one line, Notion will generate an article for you, and you already know you're gonna edit them. So it's okay for them to not get everything right. And so knowing where the expectation actually is good. And if you actually cannot mess up with that component, maybe you need to think, do you even need LLMs at all for that specific component? If you can't even go an apology, I'm not gonna think about how I'm gonna apologize if I actually kill someone. That's not something you can apologize for. Or you have to apologize, but So when it comes to things that you cannot mess up, maybe you need to rethink if you're gonna use LLMs or not. So, and I think that is all for my workshop or like presentation and some little simple demos, and I hope you enjoyed it. Yeah. Thank you. Q&A, yes.
I have a question about the last piece. Well, maybe like you talked about how was it primitive?
Yes. Oh, yeah. Primitives. Yeah.
Facilitates the consistency, latency, and the reliability of the app. But those are really addressing the non-functional requirements. But as a product manager, are there anything else that I should be not instructing, but like writing in the requirement document?
Sorry, I couldn't quite hear you.
Sorry. So what I'm saying is, so a lot of like that first half of the presentation of priming.
Oh, primitives, yeah.
Primitives are for a lot of non-functional requirements, right? Like consistency, latencies, and like the speed of the apps and so on. Are there any, like when dealing with the LLM applications as a product manager, are there any like additional requirements I should be writing? Because those just seem like like I want this app to be responding within like a certain second, so on, right?
So just gonna jump back to. I'm so hungry, by the way. So jumping back to this part, and I'm gonna put my. So. Right. So as a product manager, even though I'm not a product manager, but this is what we think. So the question is, a lot of this reason of why break it down into primitives seems to be more non-functional requirements-wise because of latency, because of costing, and etc. But how about like straight up about product itself? What do we need to think about it? And one thing that I don't think I was able to show, but is that each of these primitives, so the data enrichment of for example, our project, there is actually a lot of touch points where users need to think about, like a lot of different touch points that users use. So they don't just throw the entire thing into the system and just wait out the output. There's actually, for example, on the data enrichment side, first, catalog or categorization happens. We actually have our own internal global taxonomy or ontology of what the product taxonomy should look like. If you ever sold on Amazon Marketplace and you go onto their website and you try to classify your own thing, your own product, they will force you to go to a terminal node. It's basically a product tree, a terminal node that is to them and one node only. And that is a good practice within the industry, just so that you have a consistency in that node. You're sure it probably won't have a mood material, for example, right? So when you actually break it down into those kind of things, it helps. So the first step of there are so many touch points. The first is we gotta create categorization. There may be, while we have internal, there may be customer preferred ways of doing it. And even if we classify products, they still need to decide on, hey, do we want Do we want the what kind of attributes and values do we want for your specific node, tree node? And it may not be something like, we don't want to just extract everything because that becomes noisy. Again, like I said, a shirt or tablecloth might be called crimson, might be called maroon, but you're never gonna shop by those, right? You're gonna shop by red, you're gonna shop by blue, you're gonna shop by something that is more normalized. So what is the hierarchical on that? And then the next step then, is it even something that, how do people even edit? Or how do users say that it's a very specific customer, like auto industry, their catalog is messy. Actually auto is okay-ish, but tool was, oh my gosh, everything is just basically code rather than actual description of the things. So there may be times where you need to actually use humans for. And so there are so many touch points that you either need to think about, like these primitives can, while on one end it is about like the non-functional benefits, but on the other end they also basically represent what kind of orchestration and touch points you may have on the product side, and how do you generalize the primitives enough, like not so generalized that it doesn't do anything well enough, but not so specific that they can only do certain things. And if you have the right generalization, and this might be more of an engineering thinking on the primitives, but if you have it at the right level of kind of like abstraction of the primitives, then a single primitive can actually be used for multiple touch points. The ticket system that we talked about, when a user starts using our system, a ticket is actually automatically generated. It's actually automatically generated, and then it will decide on, okay, maybe what are the tasks in order to complete this ticket, and the ticket will then, each of these tasks will then go hit one or more primitives in order to complete the task, and some of these are just all the way automatically generated. Some of these, if there is a desire, so we do have a like some functionality that says, okay, you want to turn on the image extraction. Oh, you want to make sure that this extraction is not done by LLMs but done by humans. We actually have basically labeling vendors that are basically like mechanical Turks on the side, that if users want, they can actually dispatch these to the mechanical Turks, not the Amazon one, but our own vendors instead. But they are actually from the same primitive as well. And that's how human in the loops can also be done. QA is also a primitive as well. So I guess, I don't know what's the right term for product managers, but you're gonna have a lot of touch points, and a lot of touch points, yeah, they may be interchangeable in that sense. Also, one other thing I do want to mention, because it's funny, our industry, because of we're dealing with merchandisers, some of them may feel like may have some fears on how AI is supposedly, I don't know, replacing them and things like that. But having primitives that also, sometimes we need to think about primitives or product design way, so that we're still doing like every primitive can be done by human in our design, so that they feel like they just only need to give away, like let the AI to run what they don't want to deal with, what merchandise don't want to deal with, but they still have a good control on the things that they have based on the touch points. So I don't know if that kind of answers your question, but.
So is it like a fair to compare this like a primitive action to, like back in the days you would define attributes for analytics,
Mm-hmm.
and then you would probably explain to the technical team like this is a customer journey, this is a little challenge, these are the attributes or these are the characteristics you need. So like please do the thing.
So you mean if you can say that primitives is basically like attributes or basically of a software system basically. Yeah, I generally would basically treat it as that, as a, may not be as depending on like, because primitives does feel a lot more not lower level, but it's kind of like just a single component. But yes, it's basically, I do think it's comparable. Yes. Yeah. Thank you. Um, is there any other thoughts, question, or 5 minutes remaining is also what I see. Oh yeah, okay. Armand, do you know how this works? Oh, more like, I guess. Yeah. Thank you. Yeah. I'll just provide the links.
I think I put it in the Move app as well. So there's a link, the note. I think the last presentation they put the link over there as well. So in the app,
Oh, in the Huva yeah, app?
yeah, if you upload it somewhere,
Oh yeah, I could do that.
yeah, just give us the link and then we would go if it's whatever GitHub or.
Okay, so I guess for since that, then I'll post the link on both. I don't know if I can edit my own talks, but at least it will be on my self introduction. I'll try to put it on both. If not, just find me on Wuva as well. And I'll just ask. I can't remember her name. I think Tina. How that works as well. Like how do I even share? But yeah, I'll make sure that this is shared. Yeah. Let's see. And I do have a question for you guys. And this is relatively random. Do you guys know where around here can I find food? Downstairs? Okay, so is that like a food court or? I don't know if this is gonna be recorded or not, but I didn't eat lunch. Yeah. So yeah, thank you guys. Oh yeah. Oh, I'll check into that. After lunch. Yeah. Okay, and then I guess I'll just unplug this and thank y'all.